And then in the next, and then at 10:30, I'm going to go over exam 2 with the 004 class. So if you want, you can join that. If you don't, you don't have to. Totally up to you. But and I think also going over these exams yourselves would be very helpful. So I hope you've been doing that. Okay, 1 second. Okay, so let's begin. So the first question is, they ask us to consider the quadratic surface given by the equation. So x squared minus 2y squared plus 2z is equal to 4. And so the first thing they tell us is sketch traces of the surfaces in each of the 3 coordinate planes. So that would be for y is equal to 0, x is equal to 0, and z is equal to 0. And give the name of this surface. So first, let's draw an axis. And we can begin by setting z is equal to 0. So if z over here is equal to 0, then you would have x squared minus 2y squared is equal to 4. And this would be a hyperbola. So it would look something like this. And here over here, this is the x coordinate, and here's the y coordinate. And these points over here, well, they happen when y is equal to 0. So they happen at 2 and at -2. Okay. So now the second part, the next part is setting y is equal to 0. So this would be for y is equal to 0. Then you would have x squared plus 2z is equal to 4. And this is a parabola. So if you make your x z plane, then, well, we can move the x squared to the other side. So that would be z is equal to -1/2 x squared plus 2. So it starts at 2 over here, and it's a parabola. And these points over here, those are the points when z is equal to 0. So we can move the 2, that would be negative, and then, yeah, so it'd be 2 and -2. Any questions so far? Okay. So now let's do the x one. So here is x is equal to 0. So then we get -y squared plus 2z is equal to 4. So that means 2z is going to be equal to y squared. 2 is going to be equal to y squared plus 2 or -2. And so then the graph of this would be y. This is going to be, no, let's make this z, this y. So then it starts at -2 and it increases. So it would be a parabola that looks like this. 1 second.
Professor, wouldn't it be +2 instead of -2?
Yeah, you are correct. Yeah, because you just move it to the other side. Okay. So now, now that we have these pictures, we have two parabolas, one hyperbola, so that this would be a hyperbolic paraboloid. Okay? So that's for question 1. Okay. Any questions about this?
Do you mind drawing that out real quick?
Yeah.
The 3D model.
Yeah. 1 second. Okay. So when you have two parabolas, so here's my x, y, and z. Sorry, 1 second. I just need to answer text. Okay, so this would 1 second again. Okay, so going back up here, all of these parabolas are going to end up giving us, as we move along the these axes will give us different parabolas, some of them going up and some of them going down. So that should immediately remind us of a horse saddle, and then the hyperbolic part will give us the hyperbolic parts of the saddle. So let me see. So if this is z, and that's that. Okay, so we will in the z direction for both x and y. So in the x's, so that's x over here, we're going to have the parabolas that look like this. So that would mean we would have this over here, something like something like this. And okay, and then in the y direction, and these go up and down, so you can try to think about it like this. It is a bit hard to draw a saddle, but I guess if we draw this saddle first and then we analyze it, that might help. So that would be something like yeah, I'm not great at drawing saddles. I apologize, but it would look like a saddle. It's just a little tricky to draw. Okay. Okay, I don't know. Maybe think about it, something like this. Yeah, this isn't great. Again, I'm not good at drawing saddles. I apologize. Okay, so let's continue with the next one. Okay, consider the cylinder and the parabolic cylinder, which is y is equal to y squared. So that would just be y squared. So sorry, x is equal to y squared. So if we just look at that, that would be something like this. Here's my y, and here's my x. And then if we look at it in 3 dimensions, here's x, y, and z, then we would have something that looks like this, and then that stretches to infinity. And so something like that. Okay. And okay, and then they ask us to parameterize the curve of intersection of the above surface. Okay, and find the parametric equations of the tangent line to the curve. So going here, so if our cylinder is going to look something like y squared plus z squared, so x, y, z, and that would be something like, so you would have something like this, and then this would go on to infinity. So that would be our cylinder. Okay, not drawn great, but something like that. And then the other surface is going to be again x is equal to y. Oh, sorry, x is equal to y squared. So that would be, here's my x, here's my y squared. Sorry, here's my y. So that would give us this over here. And so that would be this over here, something like that. And then this would go up to infinity and down to infinity. And so then we get some curve coming out from when these things intersect. And yeah, they want us to figure out what that curve is. So we just need to substitute. 1 second. Okay. Fine. So when we parameterize a curve, we only want one variable in the end, and we would want that variable, for example, to be t. So the cylinder itself can easily be parameterized in terms of t. So again, we have y squared plus z squared is equal to 4. If we take y, and because of this is 4, we would take y to be equal to 2 cosine, let's say, of t, and z we would take to also be equal to 2 sine of t. Now, does this satisfy this equation? Yes, because that you plug this in here squared, you get cosine squared plus sine squared, that would be 1, and we would get 4 in the end. So yeah, this would satisfy the equation. So then we would have that x is equal to y squared, and this over here would be equal to 4 cosine squared of t. And now we have our y, our z, and our x. So we can say that our r of t is going to be equal to 4 cosine squared of t, 2, and this is from the y cosine of t, 2 sine of t. Okay, that would be our r of t. So what do they want? Yeah, find the parametric equation tangent line in the curve at the point 0, 0, 2. So the question is first, what gives us 0, 0, 2? What t gives us 0, 0, 2? So that at least we know what t we would be on. So t would be equal, and we want this to be 0, we want this to be 0, and we want this to be 2, so that would be pi over 2. Okay. And so then at that point, r of pi over 2 is going to be 0, 0, 2. Now the derivative, that's going to be over here, we're going to get 8 cosine of t times sine of t times negative, so minus sine of t minus 2 sine of t and 2 cosine of t. And so then r prime of pi over 2 is going to get us to, so here we'd get a 0, and here we would get a negative 2, and here we'd get a 0. Okay, so that's our r prime. What else did they want? Find the parametric of the tangent line. So they want the entire line. So this over here would give us our v. So in order to find the, so then we're going to start at this point. So we would have that our line L of t is going to be equal to 0, 0, 2 plus t 0, negative 2, 0. So again, this is our v over here, and this is our point r0. And yeah, that would be the answer. Any questions about this?
Yeah, Professor. So they don't indicate to us like you have to parameterize it using the r cosine t and whatnot. What if we parameterize it as like we define, for example, we define x equals to y squared and z something in terms of y.
Mm-hmm.
Yeah, what if we do that?
So you want to plug this x in here.
So like from what I did before I saw the solution is I defined x as y squared and z
Right,
as,
but I'm asking, did you plug this x into here to get x is equal to z squared? Sorry, x plus z squared is equal to 4.
yeah. I mean, what I did is I defined y as t.
Oh, okay, fine. So you took y to be t. Okay, so then
So
this would be, oh. So if you take y, so that would mean that your thing would be t over here. But then x would be the square root of t, right?
t squared, because x is equal to y squared.
And then z, so this over here would be t squared, and you would move it, so yeah, z, so z would be the square root of 4 plus t squared. Okay, so now where were we? at the point, oh, we wanted to find the point 0, 0, 2, which for t over here would be 0, 0. So you take t is equal to 0 in this case, right? So then this would be our r of t, and then r prime of t is going to be equal to 2t, 1, and 1 over 2 square root of 4 plus t squared times 2t. So I'll just put that on top. It's 2t. So these twos can cancel. Okay. And then for 0, we would get r prime of 0 should be equal to 0, 1, and 0. So yeah, so this has a -2 and this would have a 1, but it's going to be pointing, well, in opposite directions, but the line that you're going to get should be the same because you would use this point. So then your L of t will be equal to 0, 0, 2 plus t 0, 1, 0, and that would be, so whatever, L2, L1, and those would equal, right?
Okay. So it's all right to use this, right?
Yeah, that's fine.
Okay, thank you.
Professor,
Oh, sorry, yeah.
I was wondering, so on the exam tomorrow, should we be able to draw a 3D figure based on like the 3 traces? I'm still having trouble actually drawing the 3D figure.
So let me, I think that like, as long as you can draw something that kind of resembles it, that should be okay. I also can't really draw a saddle just randomly, so I understand the problem. My guess is that if they give you a problem to draw, it will specifically not be a saddle. It would be like a hyperbolic two-sheet or parabolative two-sheet or a cone or something like that. Because saddles are just difficult.
Okay.
Okay. So now let's move on to the next problem. Okay, problem 3. The curves given by that and that intersect at the point that. Find the acute angle of intersection between the curves. So the first thing that we want to do is we want to take the derivatives of both of these curves and find what they are at this point. So the curve 1 is going to be 3 t cubed plus 1 4t plus 1 and 7 plus t cubed. Then R2 of t is going to be, sorry, if S okay, that's going to be S plus 3, and S cubed. S plus 3, S cubed. And they intersect at the point 2, 5, 8. Find the acute angle intersection. Okay, so R1 prime of t. That's going to be 3t squared, 4, and 3t squared. And our 2 prime of t is going to be 1, 1, 3s squared. Okay, now when do we get this point over here? So for t, we not want a 2 over here, so we would get a 1, and then that would be 5, and that would be 8. So for here, in order to get this point, t is equal to 1. And s is equal to 2. Yeah, so s would be equal to 2. So that tells us that R1 prime of 1 is equal to 3, 4, 3. And R2 prime of 2, that's going to be equal to 1, 1, and 4, 12. Any questions so far?
I had a quick question. For the exam tomorrow, will it be the same thing like last exam where we have 30 time slots and then we just do the exam on one of those time slots?
Yeah.
Okay. Oh, and also real quick, does it go up to 3.5 or is it 3.6? I can't remember which section we ended at.
I think it adds up motions and space. So I think that's 3.5, but I'm not sure.
Okay.
Right. But it ends up motions in space. Okay, so the acute angle between them is going to be cosine inverse of the dot product of these two. So that would be 3 plus 4 plus 3 times 12. All of this over, and then we'd have the square root of this, of the magnitude, well, we'll have the magnitude of this vector times the magnitude of this vector. So that would be 9 plus 16 plus 9, 1 plus 1 plus 12 squared. Okay. Okay, any questions? Okay, and this is equal to our angle. Okay, the next one is consider the curve given by this. Find, okay. Consider the curve given by this. Find the arc length of the part of the curve between this point and this point. Find the vectors t and b at that point. Okay, so r of t is equal to t -4 cosine of t and -4 sine of t. Can anyone tell me what this shape looks like?
Helix.
Yeah. So this would be a helix, but it would be going in the x direction. So here's x, y, z. So something that looks like that. Second. Okay. So now the first thing that they ask us to do is to find the arc length from some point to another point. So the first point was a 0, -4, 0, 0, -4, 0, and pi pi 4, 0, pi 4, 0. And we want to know what t's get us to these points. So the first one is going to be t is equal to 0. And the second one is going to be t is equal to pi. So now that we know these, we can take the integral from 0 to pi of the magnitude of r prime of t dt, and that would be our arc length. So this is the same as the integral from 0 to pi. Okay, and then we would have the square root, and then this would be 1 plus, and then this over here would be negative. So this would be cosine. So it would be 16 sine squared plus 16 cosine squared dt. So this whole thing is going to be equal to the integral from 0 to pi, the square root of 17, because this, take out the 16, and you would get 1, and dt, and this is going to be equal to the square root of 17 pi. Yeah. Okay, so now they want us to find t, so the unit tangent vector. So the unit tangent vector at some time is equal to the tangent vector divided by the magnitude of the tangent vector. Okay, so that would be equal to so r prime of t is 1 4 sine of t and negative, I think negative, negative cosine 4 cosine of t. And we said that r prime of t, the magnitude, is equal to the square root of 17. So that would tell us that this will equal to 1 over the square root of 17 for sine of t over the square root of 17 and negative for cosine of t over the square root of 17. Any questions? Okay. So now the next thing that we want to know is n. So we okay, so we found that. So now they want us to find n. So n, we said, is equal to t prime of t over the magnitude of t prime of t. So what's t prime of t? So that comes from here. So t prime of t is going to be equal to 0. And then we are going to have 4 cosine of t over the square root of 17 for sine of t over the square root of 17. Okay, now what's the magnitude of this? So the magnitude of t prime of t, well, that's just going to be, so you'd have this squared, those would be squared. You take the square root, so you would end up getting 4 over the square root of 17. So now n, yeah. So now n over here is going to be equal to 0. And then when we divide by this 4 and this square root of 17 cancel this with this 4 and square root of 17. So we get cosine of t and sine of t. This would be equal to our n of t. Any questions about this?
Yeah, so in the solution, when they told us to find n pi, the solution said it's 0, 1, 0 at 0, 1, 0, but I think it should have been 0, minus 1, 0.
Oh, okay. So n pi, yeah, well, so that would be for cosine when we're here at pi, and that would be negative, yeah.
Okay.
Okay. Okay, what is up? What's more? Find the vectors at the point. Oh, okay, so then that would be n. So then t would be t pi would be equal to so second, yep, 1 over the square root of 17, 0 and 4. 1, 0, 4, all over the square root of 17. Okay, so these are the points of pi, and then they want us to find the vector b at that point. So we know that b pi, 1 second, I need to get my charger. So b at pi is going to be equal to t cross n. So let's do that. So we have I, j, k, and then we will have 0, -1, 0, or well, the t should come first. 1 second. Oop. 0, negative 1, 0, and 1, 0, 4. Yeah, so then this is going to be equal to I times that minus that, so that would be 4 plus minus j would be 0 plus k, and that would be negative 1, so minus 1. So it should be 4, 0, negative 1. Oh, 1 second. Sorry, there's a square root of 17 here. Square root of 17. So this would have square root. Okay, so this is all the square root of 17. Okay, and this is b at pi. Any questions? Okay, so let's continue. Consider the curve given by this, find the curvature at this point, find the point at which the curve intersects that plane. Okay, so r of t is equal to t squared 2t and t cubed. We want to find the curvature at 1, 2, 1. Okay, so first thing that we need is we need to know what r prime is and we need to know what r double prime is. And once we know that, the other parts, well, after that, we're just going to use the formula that the curvature is equal to the magnitude of r prime of t cross r double prime of t divided by the magnitude of r prime of t cubed. So r prime of t, and this is that point, so t over here is equal to 1. So r prime of 1 is going to be equal to, so this would be 2, this would be 2, and this would be 3, this would be 3. And then r double prime at 1, r double prime at 1, that's going to be equal to 2, 0, and 3, and then a 2 comes down, so 6. Okay, so now we need to find their cross product. So r prime of 1 cross r double prime at 1, that's going to be equal to I, j, k. And then we're going to have 2, 2, 3, 2, 0, 6. So this is going to be equal to I times 12 minus j times 12 minus 6 plus k times minus 2, so minus 4. And so this is going to be 12 and negative 6 and negative 4. Okay, so now we just need to figure out what the magnitude of r prime 1 is. So that's going to be equal to 4 plus 4 is 8 square root of 17. That's the square root of 17. So then our curvature is going to be equal to the magnitude of this. So that would be the magnitude of 12, -6, so -6 and -4 all over the square root of 17 cubed. Yep. Okay, any questions about this?
Professor, I have a question. So in the quiz, the question told us to draw R of t, and sometimes R of t is like something like 1 plus t comma t squared comma e to the t, and how would we draw that?
Well, I think that generally if it has something like draw it, it should be like a helix or something like that. So that's generally what would happen.
Yeah, that's why I don't know what to draw in the quiz. And they also told us to draw the v of t and a of t.
Oh, I think that was just the vectors at that point. Okay, I apologize. Maybe it wasn't clear. Okay.
So every time we're told to draw v of t or tangent vector, that should be just the vector, right? Not the curve.
So it depends. So if it's a helix, then R of t would look something like a helix, and then the tangent vectors would go along like this, and you can draw that. And then the acceleration vectors would be pointing inwards, but also going upwards a little, because this thing is going up. So it would look like something like that.
Do you have like the solutions to that quiz that we can look at and study from?
I don't. I don't.
Okay, but so those are the vectors, not the curve, right?
Right. Those would be the vectors, and that's what you would that's what I would mean.
Okay.
That yeah, I apologize if this wasn't clear. I'll go back and look at it again, and if it really isn't clear, then I'll make sure that no one loses points over it. Okay.
Okay, thank you.
So now they want us to find the points at which the curve intersects the plane. So I think we are kind of done, but I'm going to continue. Whoever wants can stay. If you don't want, you can leave. I'm just going to continue with part B and then do problem C, and that's that. So so we want to see when this curve over here intersects this plane over here. And we already saw how to do this last time, like before last exam. So one second. So we have x minus 3y is equal to -8. X minus 3y is equal to -8. And our curve was R of t is equal to t squared 2t t, so t squared 2t t cubed. Okay, so this intersects when you can plug in your x coordinate, your y coordinate, you solve for t, and that will tell you when they intersect. So over here we would have t squared minus 3 times 2t, so that would be minus 6t, is equal to -8. Okay, so we can move that to the other side. We get t squared minus 6t is equal to plus 8 is equal to 0. And that tells us that t minus 4, t minus 2 is equal to 0. So that would tell us that t is equal to 4 or 2. Okay, so there would be two places where we're going to intersect the plane. We just need to plug that in to our t over here, those two things, and we will get the 2 points. So r of 2 is equal to 4, 4, and 8, and r of 4 is equal to 16, 8, and 14. Okay. Any questions? So let's continue with the next problem. A particle has a velocity function this and initial position that. Find the position of the particle when t is equal to pi. Find the speed of the particle at the first positive time at which its acceleration is equal to that. Okay. So let's first reconstruct the position. So my v of t is sine 2t, 2t, and -3. So v of t sine 2t, 2t, -3. Okay. And r of 0 is 3, 2, 1. R of 0, 3, 2, 1. So my r of t is going to be equal to -1/2 cosine of 2t t squared and -3t. Oh, plus constant, sorry. Okay. Plus c1 t squared plus c2 and -3t plus c3. So r of 0 from here is going to be 1 second, we have -1/2 plus okay, -1/2 plus c1 c2 and c3, and that is equal to 3, 2, 1, which means that c1 is equal to 3.5, c2 is equal to 2, c3 is equal to 1. So now we have r of t is equal to -1/2 cosine of 2t plus 3.5, and then t squared plus 2 and -3t plus 1. Okay, now they want the position at pi. So that would give us r of pi is going to be equal to -1/2 yeah, -1/2 plus 3.5 pi squared plus 2 and -3 pi plus 1. Yeah. Any questions? Okay. So now my acceleration at some time, so that's going to be the derivative of the velocity, which is going to be equal to 2 cosine of 2t (2 and 0). Okay, so what did I want to say? Oh, so we want to find the speed of the particle at the first time at which the acceleration is equal to this, -2 and 2. So let's say this is equal to -2, 2, and 0. Okay, so we just need this. So we need 2 cosine of 2t to be equal to -2. And that would be t is equal to pi over 2. Right, good. And so then we just need to look at our velocity. So our v of t was what was it, sine of 2t, and the sine of 2t, 2t and -3. So plugging in a pi over 2, v of pi over 2 is going to be 0, pi, and -3. So the magnitude of this thing is going to be the square root of pi squared plus 1. Any questions about this? Okay, so I'm going to stop here. I'm going to try to post the videos at some point. And yeah, best of luck on the exam tomorrow. I'm going to be giving class again at 10:30, so anyone who wants to join. Okay, have a nice day.